Today we made a big announcement on the agile services networking, which is a new concept that we are introducing for the new AI era on the traffic growth and managing the service provider networks and beyond. So today we were going to be speaking actually three different topics. We have three speakers in the room. First of all, I'm going to be describing why we are doing what we do on the agile services network, and then I have two colleagues with me. Phil and Brian. They're going to be describing what is in it and which customers and how the customers are implementing actually that solution. Okay. So three agenda points. So let's start. Why now and what we do now in general. Okay. When we see the traffic and when we see the service provider evolution and the networking evolution, actually, we see AI is really impacting how the traffic mix is changing in the network implementations, right? So as of today, 30% of the traffic is driven by the AI, and we already see the evidences in the data center interconnect and the edge to network actually flowing, increased data rates with 30-35% in the networking. So that's really a mix of traffic which we were not seeing earlier in the service provider networks, which is actually triggering a new thought how we're going to address the growth, right, in this one. So by the introduction of ChatGPT in 2022. Now, in 2 years, we are seeing a huge adoption, which is 65% of the traffic has been produced in the edge data centers or in the edge of the locations, let's say. And then we're also seeing up to 65% of the organization using AI for the generation of the traffic and the content, right? That trend is expected to grow, and by 2030, we are expecting a huge growth, 120%. Year-over-year increase in the traffic and the traffic metrics, interconnecting each sites, right? So the big question becomes how are we going to address that growth and how are we going to address that adoption, right? So you can see three problems on the space. First of all, as we described, increased traffic triggered by the AI, and that bandwidth cannot be accommodated actually in the networking layers if you have a suboptimal transport, which is in today's architectures, right? So that will result in redundant investments. That will result in suboptimal SLAs in the service introduction. So that needs to be solved. That's problem number one that we are solving with the agile services networking. Problem number two is that most of the service providers needs to innovate and introduce new services so that they can generate free revenue and they can generate actually margins. However, with today's constrained scalability and let's say squeezed margins that they have, it's not easy to actually innovate using 20 years of architectures and 20 years of suboptimal products, right, in the network. So that's the second piece that we are trying to solve with the agile services networking. And of course, the changing in the traffic patterns, as I tried to explain earlier, it's a different traffic mix now. It's edge to edge, but edge is supposed to be anywhere by the by the customers and whoever is using this one. So you need to introduce the anchoring points into the networks where you can actually float the edge as a function starting from the access to the aggregation to the central of the networks without having any compromise to interconnect any endpoints, right, to each other. So this is the third point that we're going to address with the agile services networking. And let me actually describe how we're going to do that. How are we going to solve this problem by addressing with three key pillars, right? Our first pillar is actually intelligent aggregation, intelligent distribution. So what it really means is that we need to push the edge as much as possible to the end user who is consuming it, right? It means earlier handoff of the traffic to the possible clouds, to the possible endpoints. So pushing the anchoring point as much as possible to closer to the end user, right? That's going to give us an efficient service delivery, and we would be able to interconnect any endpoint without actually making a tromboning in the traffic. So east to west and south to north will be optimized by the traffic deliveries as well. This is going to provide us a network-centric actually resiliency in the networking, because now we're going to have maybe a smaller edges or smaller anchoring points for all the interconnectivity types, which is going to come up with reduced blast radius in terms of failures and easy management of the traffic while we are interconnecting the sites, right? So that's the first point. The second point I'm going to discuss with the assured convergence, right? In order to achieve this agile services networking connectivity model, you need to have edge anywhere, first of all, right? So that's really a convergence of traditionally known access aggregation and edge domains, all in a conjunction, right? The hard point is when you push the edge with this current architectures of the products and the services to the access, that becomes too painful to accommodate the cost levels, right? So you need to address in a different way, like how much scale that you would be accommodating and how much capacity you need to accommodate in these different locations, selectively. So it's going to come with, multi-layer convergence in the systems and in the architectures. Like first convergence layer, we will be talking about, the convergence of the residential and the business services. So we would like to have a common architecture, common product portfolio, and common delivery architecture for the automation and, the assured, network operations to accommodate, both residential and both business services all together. The second piece is going to come with the infrastructure convergence. We are already doing this one. Router optical networking is a great example, but we are converging different, technological layers in the networking like IP, optics, passive optical networking, all in a common infrastructure, which we can actually do any service or any access point, any access type into the networking. The third point of the convergence that's going to come with wireline and wireless convergence, which is also going to be addressed like, the mobility services plus the, the residential subscriber services. So that common infrastructure will be serving to any access types for, starting from the mobility and ending in, the regular normal, home users as well, right? So that's our second pillar. To serve the networking, having a converged architecture and converged system, which we can serve any access. So how do we achieve this in the end is actually with the resilient simplification. That's what we call, right? This is driven by the common silicon architecture, which means that across the portfolio for the pins that we're going to deploy in access, in aggregation, in edge, and in core, we're going to have a unified silicon portfolio, unified silicon one portfolio, which we can actually unify the services just by trading in and trading off like the scale and the capacity across the layers, right? Which is a huge advantage, like customers, when they need higher scale, they can actually trade this with the capacity, or they need higher capacity, they can trade this with the, the lower scale as well, right? That's number one. The second piece is that the unification of the transport layer. Phil is going to describe like, more details on this one, but that's going to be a common protocol layer on the transport. So we will be unifying the service delivery architecture here. The third piece is that we are innovating in the subscriber management side of things. That comes with the, the functional disaggregation as well. So like this new architecture will be served by the COPS architecture on the BNG, COPS architecture from the mobility side as well. So we're going to have a common control plane, which is actually talking to our automation systems and which are unifying the service delivery for subscriber management in the user planes area. And that's all going to be connecting with the overlay business services, including SD-WAN as well, right? So these are the three key pillars. Which will be addressed within the agile services. And now I would like to actually deliver the word to my friend, colleague, Phil, to describe what is in it actually and how we do that.
Yeah, kind of what is it? So agile services networking, it's an architecture, it's a solution. There's a lot of different components to it that make up what we call this end-to-end solution, end-to-end architecture. And I'm just going to touch upon a few of those today. We could spend a whole kind of 4-hour session going into a deep dive of that. But I'll really just cover the basics and kind of the basic blueprint of what it is, how it works, and how we're enabling, connectivity. As I said, AI is potentially a big traffic driver on networks in the future, but we're really covering any kind of operator service. So the idea is not just AI and the things that are coming, but all the things that providers are doing today and how we simplify those. Again, it's about creating any-to-any services. It's about taking away maybe silos of the network, where in the past we might have had an access network, a metro network, a core network, and really being able to satisfy any service needs at any point, no matter where it is in the network. The other idea is taking away potentially like, platform limitations and having to use specific platforms, specific parts of the network. It's really about being able to deliver those services across a single consistent set of hardware end-to-end across the network. So again, all these different service types over a single converged network. I think that's one of the key points Mustafa touched upon is convergence, both on the network side, and I'll talk a little bit about how we're also doing convergence on even the device side, where we can do more within a single device to allow you to simplify the network, remove devices, remove protocols over time. It's really about simplification. I think something we've kind of touched upon a lot in the past is really network simplification. That's really the key to networks that are easier to operate and easier to manage over time. I know I just said the word simplification, but again, it's all about simplifying networks. So service optimization, one of the key tenets, and I'll talk a little bit more about this, is like segment routing. So obviously Cisco and segment routing kind of go hand in hand. They have for a number of years. But when you look at the actual kind of forwarding plane, control plane of the networks that operators are building today, Any new network today is built using segment routing. It's a way to simplify the network. You're removing protocols from the network. You're enhancing, services with the network, and you're adding capabilities for things like traffic engineering, the ability to assure the network, and I'll talk a little bit about that, is all enhanced by using segment routing. So it's really the building block that we use to build these, I don't want to say next generation networks, and it's really the foundation of what we're doing with agile services networking from a control plane, forwarding plane point of view. Again, we talk about device convergence, and it's the ability to do more functions within that single device. We've talked about routed optical networking now for almost 5 years, and that's the convergence of IP and optical on a single device, and eliminating a layer of the network and extra hardware that you no longer need. We're doing the same things with like PON. So we have a routed PON solution, very similar. We're able to do things like put an OLT within the device. Now I don't have to have that extra hardware sitting outside in the network. And we're also doing those things with security. So I'll talk a little bit about DDoS. So being able to distribute DDoS protection to any part of the network. So we're able to really do DDoS detection and mitigation on any router in the network, which is a little bit different than the architectures that are currently deployed, where I might have centralized detection, I might have centralized scrubbing, and we'll move away from that and really distribute these functions throughout the network, and they can really be deployed anywhere in the network. I think that one key point Mustafa made was distribution of services and distribution of these advanced functionalities over time. We'll talk about Silicon One. And these are all things that Silicon One is a big part of, I think, the launch messaging and the keynote today is really extending what we've done with Silicon One over the last 6 or 7 years, which is mostly focused on really high bandwidth applications and enhancing those chips, enhancing that line of hardware to serve more edge functionality. So it's really now we have this kind of end-to-end unified story with Silicon One, all the way from the access to high-speed core interfaces. Like I said, that's sort of a key thing that you'll see as new hardware comes out, and I'll talk a little bit about a couple of the devices that are coming out just now and in the near future that kind of satisfy those. We won't go through this whole slide, but really it is about taking what you saw in a lot of legacy networks, the way they're built with kind of the laundry list of protocols for doing things like MPLS label distribution. We eliminated a lot of that with segment routing. So we simplified the network. Segment routing just uses the IGP to distribute additional MPLS label information, or SRv6 can even simplify that even more. And it's really about eliminating all those layers of the network and simplifying that. But then we take that to things like the sort of transition from IP to DWDM. That's where routed optical networking comes into play. So we're eliminating a whole layer of this sort of electrical to optical transition and shrinking that into a pluggable optic. So a big part of the launch today was additional coherent optics that we're going to use to enable longer reach 400 gig as well as 800 gig, just in a pluggable optic that plugs into a whole set of routers that we offer. So again, it's about simplifying layers of the network, eliminating duplicate hardware. And again, doing the same thing with, there's something we call private line emulation, which the traditional OTN networks that carry fiber channel, OTN, SONET services. Now we can do the same type of function within hardware on a router. So it's really about enabling the network to carry services, even non-IP services. So we have that single converged IP network now that can carry services that are not just even Ethernet and IP. They can carry fiber channel transparently over the network. So again, it's all about eliminating layers and simplifying that overall architecture.
I have a question on this slide.
Sure.
So there's plenty of Cisco terms in there. So how much is in terms of the interoperability between the different vendors? There's obviously on the left side, there are some standards. On the right side, are these standards?
Yeah, so when we talk about routed optical networking, it's pluggable coherent optics, and those are absolutely driven by standards. Whether they're OIF or OpenZR+, and we've been doing interop events now for years with that. And we're not the only ones offering. From other vendors, you might hear it called coherent routing, something similar to that. Lots of interop there. Like I said, it's really pluggable DCO, ZR+ optics, highly interoperable there. Private line emulation, there's some things we're doing there on the interop side. Right now, that's a pretty unique Cisco solution. You'll see at events like OFC that's coming up in a couple months. You'll see that we'll be doing an interop there with private line emulation as well. And the standards that drive that, there's some hardware stuff there that's a little more secret sauce from a circuit emulation, but all the control plane standards are all being driven through the IETF, and they're all multi-vendor.
Okay, so certain features will be probably supported only if it will be Cisco to Cisco.
Yeah, some of them, like the private line emulation, there's some innovation we have there that we just happen to come out with first. But we do see others that are looking at that. And again, the control plane of that is all standardized.
Okay.
It's EVPN based. It's, exactly, there's some additions we're making to it, but we're making sure that it's not just a Cisco only thing. It's there's a whole ecosystem around it.
Perfect.
Yeah.
Thank you.
So I'll talk just a little bit, a few slides about individual kind of innovations. I touched upon these earlier, and Mustafa also touched upon them as well. Again, Cisco 8000, Silicon One, and extending that family to satisfy more use cases is a pretty key tenet of Agile Services Networking, and that's something we'll just continue to build on over time with that portfolio. And again, extending coherent optics. Like I said, routed optical networking has been very successful in collapsing those layers, but being able to address more use cases with longer haul optics, and also with 800 gig. So 800 gig is kind of the next evolution of those coherent optics, and being able to do 800 gig single wavelength over traditional DWDM systems. But then we talked about hardware and a lot of those things and convergence, but also the automation and the management software that goes with it. So when we talk about Agile Services Networking, it's not just about the hardware, it's about the software that manages the network as well. And that involves the last two bullet points there. Crosswork Network Automation, that's the brand name we have for our family of management software that manages these higher scale SP IP networks. And you'll see provider connectivity assurance. I'll say formerly a CDN. So it's taking what they did in terms of being able to do monitoring and assurance with sensors at a very large scale, and pipelining that data into their systems, collecting it, doing alerting. But then obviously with Splunk, we have the ability to even do further integration between provider connectivity assurance in Splunk to add even more sort of, I'll call it, business data into what we're doing with the data that's coming from PCA and from the network. And we really look at the network as a sensor. I won't talk too much about this today, but segment routing has a wealth of different things we can do to monitor paths in the network. We can monitor latency and loss. We feed that upstream into tools like PCA, where that data can be aggregated, it can be viewed, it can be monitored, and then we can also do additional alerting on that. And from there, it can go into systems like Splunk or integrate into other systems. So you could get more sort of business value out of that data that you're getting from the network. So it's really about being able to do the end-to-end monitoring assurance for the new infrastructure that we're building and the sort of new applications that we're going to have to.
So this assumes that actually you would have the pack computation element and collecting all the data and then filling into Splunk so that you can get some intelligence out of it.
Yeah, potentially, yeah. Like I said, that's where we probably would have put this sort of the PCA collector in front of that too, to get another level of aggregation and sort of data enrichment. And then, yeah, that would go into Splunk, and then potentially, like I said, be combined with sort of business data, even more metadata. So yeah, the idea is, that data, whether it's a PCE or some type of other sensor that's built into the network, all that data flows upstream.
Thank you.
And so is there any, vision, what we've seen this morning at the keynotes with the GPUs and stuff, like, is there any sort of a vision of, looking at that for the service provider world?
I'll say we're definitely looking at it.
Okay.
So we're not announcing.
No commitment, but you're looking.
That was on the Nexus side of things.
Yeah,
but,
exactly.
Yeah. But no, definitely looking at it for applications that require more advanced packet handling, things that just aren't really that doable today in high-speed NPUs. But yeah, absolutely looking at those.
Because there would be in line what you were saying at the beginning, right? Like streamlining everything you're doing end to end. So using same architecture, I guess.
Right. Yeah. Like I said, there's definitely high-touch packet handling functions that are better suited for a DPU than a network processing unit. So we're definitely looking at those types of applications.
It does seem like a way to go, though.
Yeah.
Because anyway, the moment you're then unifying the infrastructure, in the case of router optical networking, they got rid of the device that was doing then the serialization between Ethernet and the optical network. So once you get out of the way, then what are you gonna do to optimize packet handling, serialization, delay, and all those things that you can beat with simple physics? You have to get a bit more creative. But the moment you simplify it and it's everything is designed all the way from the beginning till the end of the network, then it does make sense that then they would apply all that power that Silicon One would have. Because then if everybody has it, then what's the point of not making use of it?
Yeah.
But probably it's a bit early. But if it's a Nexus, it will eventually land on some other product.
Yeah, so Nexus may be leveraging that for advanced, security, purposes, and there's other SP things that we could potentially do with that DPU. And again, like you said, it's about eliminating extra boxes in the network that have specialized functions and being able to combine those into a single device just to minimize footprint, minimize management of that.
Like a subscriber management, et cetera, right? Using the DPUs for that.
Yeah, I mean, you could think of applications like NAT, things like that, modern high-speed NPUs are not great at doing. But those are applications to me. Those are things that we're looking at sort of for the future and those types of applications. This is just an example of some of the newer devices that we're releasing. Like I said, you see most of the 8K or Silicon One 8000 base series devices today are high speed, up to 25.6 terabits in a single fixed platform. But these new platforms are modular. They're a little bit lower bandwidth. But they're meant for edge services. So there's things like edge service scale that's quite a bit higher on these devices. And then we'll have, traditional what we call access. Like I said, we don't really want to, pigeonhole these as access and edge. The idea is to support a common feature set across all of these devices. So today you might pick a specific platform just because that platform supports feature X. Another platform that's a higher speed platform, doesn't support that feature. The idea is really to only pick a platform, I think Mustafa said, based on the bandwidth needs you have and potentially the port speeds you need, and not so much the chip and a specific device for a specific place in the network. So again, these are a couple of the new systems, and the K100 processor is the newer processor that we have on the Silicon One side, focused on edge. The A100 is a lower speed processor, but it's focused on lower speed applications that are usually kind of the access and very far aggregation parts of the network. But again, it's a single architecture with Silicon One end-to-end, and the idea is to be able to deliver these features ubiquitously across all of those different devices, no matter where they're at in the network. And I've got a couple slides just on routed optical networking. Like I said, this isn't new. We talked about it, I think, at Tech Field Day over 4 or 5 years ago now. And it's really about taking what you see on the left is all these layers of the network, potentially shrinking those down. It's eliminating. And you can kind of see the simplification story there. Traditionally in these networks, the way they were built, the DWDM networks and things like that, you have transponders, you have a lot of gray optics, you have to interconnect to all of that. We shrunk that all into a pluggable, and that's, like I said, that was done 5 years ago, and we're continuing to evolve that over time to increase the speeds and capabilities and lower the power that those optics use. So when you look at Cisco devices today, and these are QSFP DD optics, that are shipping today, but pretty soon we'll also offer these in a QSFP 2800 gig form factor, which really unlocks a lot of applications for more devices, the ability to use routed optical networking. It's something that just makes sense. Today we have over 200 customers that have this deployed, just because it's, I call it kind of a no-brainer technology. It's just something that you're eliminating devices in the network, you're eliminating complexity. And it's cost effective, and it's from a both CapEx and OpEx perspective. And Brian will talk a little bit about that and some of the customers that we have deployed this at larger scale today. And again, the optics that we've used for routed optical to date, they're 400 gig optics, but they support multiple speeds, but they do require like a QSFP DD port, which limits some of the reachability and deployment of those optics. So very soon we'll release a QSFP 28 100 gig ZR, which is a tunable DWDM 100 gig optic that's in a QSFP 28 form factor. It's always been the limiting factor with that. It's always been power. Like QSFP 28 ports were always meant to be very low power ports, about 5 watts. A 400 gig ZR optic is around 20 to 23 watts. So you can't really support that in a QSFP 28 port. But technology continues to advance, and we've shrunk the power usage of the chips that drive the DWDM to a within a 100 gig speed to something that's less than 5 watts. So these are great for access rings, aggregation rings, things like that, or even point-to-point dark fiber applications, where now I have a tunable 100 gig QSFP 28 optic. And then on the high-end side, we're continuing to advance what we're doing in DD and 800 gig. So 400 gig ULH takes the reach from a 400 gig coherent optic, which is about 1,300 kilometers, and the current shipping sort of version of that, to now something that exceeds 3,000 kilometers. So some of the really long-haul applications that we couldn't reach at 400 gig, in the past few years, those are going to sort of go away now, as we have ULH optics that have a much longer reach. And those will be supported across all the devices that we support 400 gig with today. And then 800 gig, ZR+. We're starting to see more interest in that. We recently did a couple of press releases with 2 carriers in Europe that have tested 800 gig ZR. And it's really about these high bandwidth interconnectivity, things like DCI, where we're addressing those needs with 800 ZR and 800 ZR+. Obviously, the reach is not going to be quite as long with 800 gig, but it's very high bandwidth applications. And those are things that are coming, middle of next year, or middle of this year, I guess, 2025. As I said, we'll continue to evolve optics over time, and we're even now looking at the next generation of those beyond 800 gig. I mentioned segment routing as a foundation for how we if you take the layer above sort of the infrastructure piece of the network and how we address, how packets are carried over the new infrastructure. Segment routing is really the base of that. People typically ask, we have 2 flavors of forwarding planes with segment routing. It's really the same architecture with 2 different forwarding planes. There's SR-MPLS, which has now been around for quite some time, and it's pretty widely supported across the vendor community. SRv6 is the IPv6 variant of that. And it really takes what we've done with SR-MPLS, and it simplifies it even more. You're really just doing IP routing. You get all the same capabilities you get with the MPLS forwarding planes, just simplified with IP. We could do things like aggregation of space. You think of traditional IP MPLS networks, you have to have a loopback address like a /32 that has to be reachable from every other part of the network. You can't really aggregate that very well, so you still have to distribute a lot of routing information end to end. With SRv6, I can use aggregation. So I can have one part of the network that's all behind like a /48 aggregate route. And I don't lose any of the same kind of TE capabilities. So there's ways that we could still do, end-to-end traffic engineering, but a network that might have been, 50,000, BGP LU routes, I can now simplify to, 40 IPv6, routes. It's really as many regions as you have, you can simplify the network. So we've seen very large networks, where if you look at the blueprint of how those are built, SRv6 have very little routing information. And the less state, the less routes, the less scale you have to deal with, it makes the networks much simpler to operate. You can use things like traceroute. If a VPN service is really just an IPv6 address. It's a constructed IPv6 address, but you can trace route to your VPN service. I don't have to look at a stack of labels for a service anymore. I can just simply look at a v6 address and know exactly which service that's going to. It also allows us to do things with network programmability that we weren't quite able to do with MPLS, just based on the scale that it gives us over time. So one thing we're doing, with SR, and there's a lot of SR innovations. I just picked one to highlight today. Is something that we call integrated performance measurement. It's a combination of what things that we're doing with hardware as well as SR and SRv6 software, but it's really, you can call it IP performance measurement. This all just operates on the IP layer. But it gives us the ability to, from a hardware node, to measure every path across the entire network at high scale, and we report back on this. The question I kind of posed earlier, we've used the network as an assurance sensor. In this case, we can get the data from every path on the network between any 2 nodes on the network continuously, and you'd be able to report that into the tools that we have on the automation side, like PCA and like Crosswork. So it gives you a lot of data in order to provide assurance to the whole network. This is monitoring the underlying infrastructure, but then I can add service layer data to that as well in order to correlate between the service layer of the network to the underlay part of the network. But in some of the newer hardware, we could send these probes as fast as 12 million probes per second. I'm not sure you would do that in a production network, but it gives us the ability to measure ECMP paths up to 128 ways if we wanted to continuously. And again, you have to get the data out of the network, but the data is there in order for us to do more actionable correlation and assurance than we really could ever do before. So again, that's just one innovation that we're doing with SR. In addition, it's like measure the latency per link, latency loss measurements within the network, and that all gets fed into external systems that we then use to correlate that data to the services that are carried over the network. I think we mentioned a couple times around like device convergence. We look at, today we have kind of many different components that maybe sit, outside the router, whether it's a transponder, a PON OLT, OTN devices, DWDM systems. And we talked a lot about routed optical networking, and that's a pretty simple example of shrinking that into a pluggable. But again, with technologies like routed PON, we're able to do the same thing with an OLT that's doing XGS PON services. So I might have a router that's deployed somewhere on the network that's doing business services, whether they're fiber-based or some other type of business service aggregation. Now I can also offer PON endpoints off of that as well, versus having to deploy a different OLT device, which is what's typically done today. So that we call that kind of device convergence. It's really being able to combine that. The other thing that we leverage more and more today is the ability to do application hosting on the router. So we can host third-party applications, and one that we're leveraging today does DDoS protection. I mentioned earlier now that we can distribute DDoS protection and scrubbing really any router in the network, and we're doing that through that third-party application hosting infrastructure that we have that's specifically built within iOS XR. And it gives us the ability to not just converge the hardware on the network, but then also a lot of software functions as well. So again, it's that simplification that's really the key part that we're looking at with kind of agile services networking in order to simplify the network and be able to offer these different services everywhere across the network. And then as new services come up, it gives us the ability to even leverage applications that we haven't even looked at quite yet for more advanced functionality.
One question for that. So totally makes sense to condense everything, to simplify. How is it with the telemetry from your perspective? Do you still have differences in the quality of the measurements if you're going over an optical interface or a normal routed interface, or the telemetry data at the end of the day you have the same quality no matter how the interface is looking like?
Yeah, I think the key part is to have like the telemetry. Like if you're talking about the hardware convergence part of it, yeah, you have to have the same telemetry that you traditionally had in that other platform. You have to replicate that, and we've gone to great lengths to do that. So if you look at routed optical, like there's the telemetry that you typically get off like an optical transponder. We have all the same telemetry that's on the router for that port on the router. Same for PON. So there's a wealth of PON data that's available, and yeah, we have to replicate all of that same data on the router.
I imagine if you, let's say, normalize all these telemetry data, yeah. Back in the days, we had different islands, yeah, and then people needed to compare the different quality of telemetry data. If you unify that, also makes everything much easier to, let's say, scrub and then maybe send it to something like Splunk for additional analytics and so on.
Yeah, I think that's really important, especially on in most networks that service provider networks are not single vendor; they're multi-vendor. So like you said, that data normalization piece is pretty important when you look at multi-vendor, and you do have to have some system that's going to normalize that data. Ideally, you have models and that you can use on the devices that are standardized. That's not always the case. So yeah, we'd still have to do some type of normalization at some layer in order to get into those higher layer systems. Yeah, absolutely. And we do try to use open models where we can. So when you look at things like the ZR optics, the DCOs and routed optical, we implement open config models that are pretty standard across the industry for that function, and support those and try to support the latest versions that we can in order to make it less painful for operators to adjust the data and get it into a system that especially when they have multiple vendors involved. Yeah, I talked a little about routed PON. Quite simple. It's taking a pluggable, an OLT, which might have been in a chassis, plugging that into an edge device. So again, I might have EVPN type services that are for business that are on the same device. I can then leverage the same device for kind of multiple functions. Right? Like I said, it just makes sense versus having to put an OLT at a remote location or backhaul traffic via transport or some other means to a centralized location. And these are all components that are part of what we call agile services networking. Like I said, there's more of them we can talk about, but the idea is to have all these be part of a seamless solution. We talk about secure DDoS edge protection. That's the distributed DDoS that I've been talking about, where we run these containerized DDoS functions within the devices. And we support a couple different use cases. One is traditional DDoS at the edge of the network where you're peering or it's an internet transit connection. So we can put that secure DDoS edge protection container in that peering router and do the scrubbing right on that router. So the detection happens there. There is a centralized controller that manages all of those functions. It's quite easy to even deploy. That centralized controller will deploy the DDoS container to the devices automatically. So it's not you don't have to do a lot of CLI type of things in order to get the container and the application on the router. It's all managed centrally. So if I want to have that type of functionality at one point in the network, I can easily deploy that, and then that device is ready as basically a scrubbing agent for the whole network. And then also, protecting internal parts of the network. So let's say I want to, I have some customers that I don't really trust, so I'll put that type of function on a router that fronts that sort of residential part of the network that can protect, the rest of the world from my customers. It's not just about traffic that's coming into your network. It's potentially putting what we call kind of DDoS detection and mitigation all around the network. So it's both protecting your network from some of your users or the rest of the world from your users as well. Like I said, there's quite an innovative thing that we've done with building it into the network and eliminating things like centralized scrubbing and centralized detection.
I have one question to the DDoS protection. Are you doing this more or less based on sources or also on services that you say, okay, this customer has maybe here DDoS running, this bot is producing traffic on this certain, let's say, port, we just block that, or would it be the whole traffic for a certain source or destination?
Yeah, it can be granular even down to like a traffic payload. So it's a traditional like DDoS, it's an advanced DDoS sort of detection engine. It's not just based on a volume of traffic. There's signatures that are matched. So it does, I'm not going to call it AI, but maybe machine learning type of activity that's being done there to identify those attack flows. And it'll deploy as granular of a rule as possible in order to block the traffic. So it's not just by source destination IP. So it depends on the attack that's being carried out, but it's not just going to black hole the traffic for that whole customer IP or IP block. It's going to try to do it by source destination port, or even, as I said, as granular as like a payload signature. Yeah.
So in best case, the customer is running a ransomware, sending large amounts of DDoS to a certain service is blocked, but he can still watch Netflix without any problems. Yeah.
Ideally, if it's there's ideally that could happen.
Okay.
If you're not filling up all the internets, but that's the whole point is because there's critical businesses get DDoSed all the time. There's critical services that, and it might just be an amplification attack that's just garbage traffic, but you have business critical traffic that they still want to get through. So the idea is, you don't want to block all of that, just the part that you.
I think in the past this was one of the major problems. If you block everything, and sometimes, I don't know, you block the IP, let's say from a university, and you're just not affecting the single user, you're affecting the whole business or so, yeah.
Yeah, and that's where we providers typically had more advanced sort of scrubbing infrastructure that did that. You're backhauling all the traffic to a scrubber and then just peeling off the bad traffic there, and then you have to find a way to backhaul that back to this. This allows you to avoid kind of all of that sort of complex, clean and dirty type of networking you had to do on both sides of that function. I talked a little bit about automation, and again, Crosswork Automation is our family of automation products. We have something called Crosswork Network Controller, which is really what we use today as an end-to-end management system for the IP layer of the network. So whether it's EMS functionality like monitoring alarms or software upgrades, but then it also has more advanced sort of TE capabilities in traffic optimization as well. So It's a platform, and I could spend a whole session just talking about Crosswork, but it's really for doing things like EMS function, as well as service provisioning of the network. Within the family, we also have like Crosswork Planning, which is a traditional IP network planning software. For those that are familiar with like Cisco Way, that's sort of the evolution of Cisco Way, is a new platform called Cisco or Crosswork Planning. But then we can also do management across both IP and optical as well. We talk about routed optical. We have to manage those end-to-end DWDM connections. We use something called Crosswork Hierarchical Controller to do that, where we can manage both the IP layer of the network and those probably DWDM services over that network, as well as the underlying sort of DWDM photonic infrastructure. So again, it's really about end-to-end automation across every part of the network is covered. Like I said, when we come out with this new solution architecture, we don't want to leave out how we manage then monitor that network. And Crosswork is kind of how we're doing that.
So is Crosswork having, on top of all their shooting functions, then is also being able to work as your PCE? What are all the functions that are included there?
Yeah, like I said, I don't have a lot of time, but the PC is definitely part of it. So we do have something called SRPCE, which is embedded into the network. So for basic PCE functionality, we use that component of it. But it is a part of kind of the bigger Crosswork family. And then for some more advanced PCE functionality, like when we look at congestion management, there is a more advanced PCE that's built into Crosswork that does congestion management, and it can do things we call tactical traffic engineering to reroute traffic during congestion periods. And that we do use an advanced PCE. We also have something called circuit style segment routing, which is a way that, to maintain things like disjoint paths across the network, bandwidth reservations.
Another way of saying, another way of doing SR is just that you're not just having these unidirectional tunnels, and you will just do it using the protocol extensions, which is wonderful.
Right.
So it's just the big service having Crosswork, and you have several modules, and each one of them is doing a different thing, but it still is the same.
Yeah. It's all under the family and the umbrella, but there's a lot of different functions within what we call Crosswork Network Controller. And again, some of those advanced PCE traffic engineering functions, it's just another module within that overall controller.
Wonderful. Thank you.
I talked a little about provider connectivity assurance, and like I said, call it formerly a CDN. And it's really the ability to bring in a lot of data from different sources. We talk a lot about network data. Data can really come from anywhere. They have a pretty flexible collection infrastructure. And the ability is to aggregate that data, get more visibility into the data. So there are some machine learning things that are being done at that layer of the network, and also do alerting based on that data. And one nice thing with that platform is the ability to do things like create dashboards to be able to look at all the data in a meaningful way for operations teams. That's probably, or even customer portals or building those types of things. So that's one of the key tenets of PCA or provider connectivity assurance. But then also being able to feed that data into other systems like Splunk, where you can then do more data correlation and more kind of, I'll call it metadata that you're adding to that data in order to get more business insights out of that. Within this like agile services networking, there's a bunch of different use cases. These are just sample use cases where we're building dashboards and advanced monitoring with PCA, and we're taking in most of these use cases, data from different, not just the network, but even the SD-WAN overlay. So in the SD-WAN use case, we're taking in data from the network infrastructure. We're taking in data from Catalyst SD-WAN Manager, and then we're able to do correlation between those two layers within PCA. So I said that's sort of one of the key tenets, is to be able to take all this data from, say, disparate sources in the network, combine that together, analyze it, and alert on it, in order to be able to combine those views that typically providers didn't have before. And even when we look at routed PON, it's not just looking at, say, a PON OLT, it's also looking at the overall PON landscape as well as the subscriber management piece of it. This is my last slide before I turn over to Brian real quick. But what comes out of this, we talk a lot about sort of agile services networking. What comes out of that, and it's really we have different use cases that lead to kind of validated solution designs. So we have our own labs where we set all of these things up, we validate them, and then we produce content like solution guides. as well as end-to-end user guides and implementation guides. So we don't just want to talk about it, we want to build a validated design and publish that. And we've done that before with things like converged SDN transport, which is an architecture we've had in the past. So we really want to enable providers to have network blueprints so they can implement these in a repeatable way. And it doesn't mean you have to implement everything that we're talking about within the solution. You can obviously take pieces of that and implement it in the network as needed. But again, it's an important part of what we're producing here is the ability for operators or SEs or people internally and externally to consume these different solution architectures and implement them in their networks. And with that, I'll turn it over to Brian, who talked a little bit about some customers that are kind of doing just that.
So I think you've seen here, a lot of the capabilities, but it's good to put the reality on it now. Do we have customers that are actually on this journey? And that's important to see. It is a journey. This isn't something we thought of a few months ago. And so we do have a number of customers today that we're already been working with for a number of years and hitting their goals and actually as we go forward. So if you look here, there's a number of different ones. There are a lot of different areas, different segments, different parts of the world. But if we just briefly look at some of them, you've heard already, the likes of BT, British Telecom, obviously based out of the UK. And again, you'll see common objectives of what they want to get, right? You'll hear this word simple. You've heard it all over our presentation. You'll see it all over. We need to get simple, secure, and the word resilient. They're really, and really what they've done with their global fabric here is really going and achieving that desire of network as a service, or NAS as a lot of people refer to it now. And again, the building blocks upon which you'll see today in our agile services networking, they are key to how they want to go around building network instances, around doing multi-cloud connectivity, offering an SLA visibility, and again, connecting services to that. And that's all part of what we're doing today. We're further enhancing how they can develop these services. The likes of Bell, you'll hear things as well around, how do we get low latency? How do we actually get things like IoT connectivity? And obviously the road to SRv6 and SR is very key for them. But very key here as well is removing the complexity, reducing the layers. They talk about, transponders, taking transponders out of the network and coherent optics. It's all about collapsing the layers, making it more simple. And again, you'll see some of these here, the likes of OTE. It's very interesting, obviously part of the DT, Deutsche Telekom group in EMEA. We talk a lot here again about, how we simplify down, but even simplifying down subscriber management. You'll hear announcements around kind of like control and user plane separation. So how do we get better availability, resiliency into the network? How we get better visibility? How you have better use of IP resources. So there's a lot of different operators and a lot of different segments here. But again, if we actually look, and we look specifically at a couple, you'll see Swisscom here. And Swisscom, most people know, is a tier 1 operator or telco in Switzerland, have entities in Italy now as well. But clearly they are, a mobile provider, IP provider, residential and TV, and had a number of different networks for all these different segments over the years. But what they actually found is they needed to take that complex, fragmented network infrastructure and make it more simple. Actually, at the same time, while making it simple, the word you'll hear over and over again is sustainability, power reduction. And definitely as we go into the world of AI now, power is becoming very, very important and in both their goals, but their objectives for scaling going forward. Again, very important, while they converged the network, so they took their parallel networks, and you saw a reference to 20 different networks. I think that was clarified a lot yesterday with saying really it was more 20 different platforms, converging them down into a single platform. But how do I make it simple? How do I make it reliable and streamlined? And how they actually did that was common hardware, common Silicon One from end to end, with a common platform, with the optics come from end to end, but also we talked about resiliency and digital resiliency, which was really key for them. So you see even our customer experience, how they actually did their CI/CD, continuous integration, continuous deployment of software and features as they changed that network. So again, really using the principles, what we see in Agile Services Network, the innovations, they've taken their network forward. And their OpEx in general has reduced by an estimated 40%. But as you said, the biggest gain they see, and talk a lot about 90% reduction in power consumption, with massive increases in availability and reliability right across the network. If we take another example of someone that's very much on the road and really kind of doing a lot of innovation in this area is Colt, which is one of the global digital infrastructure providers. Again, mass kind of reachability, over 1,300 data centers that they reach, over 33,000 buildings they connect. But these are probably one of the leaders again in this network as a service. And really what they achieve by that is, how can they have cloud-like consumption of the network? How can have the visibility that we've never seen before? And that's what they really prime a lot of their capabilities around. Again, getting a lot of other advantages as well. So very, very clearly, they have very, very demanding customers. They really want to get kind of large scale. How do we actually get to the simpler network operations, but also getting the balance between, cost and scalability and simplicity at the same time. One of their key areas here is that over 80% of all their connections in the core in EMEA are using routed optical networks today, and increasing all the time. But it's the last two areas here that they cause a lot of differentiation. Simplified automation, programmability, on demand, cloud-like. That's where their differentiation. But you'll see here, and we talked about Cisco Provider Connectivity Assurance, that is actually the tooling that gives them the assurance, but also the visibility. Do I offer the service? Yes, I do. And here's the visible way to see. So they have an absolutely cutting edge user dashboard that end users can see what services they are getting. So, enhanced customer control, increased satisfaction, very, very scalable, very cost efficient, on demand. And again, they're seeing 50% OpEx reduction in this area already, along with, as we said, 97% again in energy use. Again, massive goal for them. And then finally, just taking another example of someone, Aurelian, again, based in EMEA, very much in the Nordics, but they are, an internet backbone, and they're the world's #1 internet backbone at the moment. But again, how do you get similar kind of goals? And you'll see a commonality between all these, right? How do we make it more simple? How do we make it cost optimized but highly performant? But then getting the bandwidth to the levels that we need. And so a big driver here again is the scale of Silicon One, common hardware from end to end. Coherent optics and being able to go up to 800 gigs is a massive, massive driver over longer distances for them. So again, the whole RAN networking is a big part. But you'll see again the commonality here in the final two pieces again is, how do we get that visibility? How do we get the assurance? I offer it. How do I do the monitoring from end to end? But also, how do I get that programmability? It's all about, how do I get the consumption through APIs, through a programmability of the network? So again, very much the end result, what we get here is very much a cost-effective network architecture, a more simplified, easier to operate from their point of view of management, but also very much, reduced energy consumption and carbon footprint on their network from end to end. Again, very much backlined by, as you see here, 64% reduction in their CapEx by streamlining and simplifying the architecture. So I think, again, with that, you've seen the guys, they've introduced what the industry is doing. We've seen what Agile Services Network is delivering from Cisco, but also you see here many customer references that are actually now taking advantage of these innovations to actually deliver differentiation to their customer. Thank you.